The title of this lesson is Simplifying Perfect Squares and Radical Expressions. So as I go through the problems, you should be filling it in on your note page. We did some of these problems in class, so some of this will be a review, but then we're going to add some new things to it. To start out with, we've got a simple problem, the square root of 16, where we're just asking ourselves what number times itself is 16, and of course, that would be 4. In the second example, this negative sign in front of the radical really means what is the opposite of the square root of 16. So again, the square root of 16 is 4, and the opposite would be negative 4. In the next example, we have a negative sign as well, but this time the negative sign is inside the radical. Whenever you have a negative sign inside the radical, we say that this expression has no real roots. And the reason for that is because there is no number that you can multiply to itself that's going to ever give you a negative answer. Since we know the square root of 16 is 4, by doing positive 4 times positive 4, we would get 16. And if I thought maybe the answer was negative 4 and I tried that, negative 4 times negative 4 is still positive 16. So you can see that we don't ever end up with a negative 16. That's impossible. The only way to get a negative 16 would be to do a positive 4 times a negative 4, and then that's not multiplying the number to itself. That's multiplying two different numbers. In the second row, we've got the square root of 121 minus the square root of 16. We want to start out by simplifying the radicals first. So the square root of 121 is 11, and the square root of 16 is 4, and then we subtract them and get 7. In the next example, we have subtraction inside the radical. So we need to do that first before we find the square root. 96 minus 47 gives us 49 when we subtract it. So what we're left with is the square root of 49, which again gives us 7. In the last example, I have a number right up against a radical sign. That tells us that we're going to have to multiply. So I'm first going to simplify the square root of 81, which gives me 9. I'm going to bring down the 2, and because they're right up against each other, I know I have to multiply them, and 2 times 9 is 18. The next set of examples involves finding the square root of a fraction. So the first thing we want to do is we want to find the square root of the numerator, which is the number on the top. After that, we're going to find the square root of the denominator, which is the number on the bottom. And then finally, we're going to simplify it. So if it's not in simplest form, we're going to reduce it to lowest terms. Our first example is the square root of 16/49. We can rewrite that as the square root of 16 over the square root of 49. The square root of 16 gives us 4, and the square root of 49 is 7. That's already in simplest form, so the answer is 4 over 7. The next example, we can rewrite this one as the square root of 25 over the square root of 9. The square root of 25 is 5, and the square root of 9 is 3. So this is almost in simplest form. We may leave it as an improper fraction, 5 over 3, or we could also rewrite that as 1 2/3. The next example can be written as the square root of 81 over the square root of 100. The square root of 81 is 9. The square root of 100 is 10. So our answer is 9/10. This last example might trick you. You may start to figure out what the square root of 36 is and then the square root of 64. However, like we learned previously, whenever there's a negative sign inside the radical, that automatically tells us that this problem has no real roots, no solution. There's nothing that we can multiply to itself that's going to give us a negative answer. Before we simplify expressions that have decimals in the radical, it's really important that we review place value. This first example is normally read 0.78 or 0.78. However, we need to make sure that we're reading it using the proper place value, which in this case would be 78/100ths. If you're not sure about that, you can use the table that I have up at the top. Just place this number in the table, 0.78. When you're finished writing the number, whichever place your number ends on, which in this case is hundredths, is going to be the place value of that particular decimal. So we would read it as 78 hundredths. The next number has 4 digits after the decimal point. It's 0.2165. So again, you might not be sure how to read that. You can use the table again. So 0.2165, and you'll see in this case that the last number ends in the 10,000ths column. So when we read this, we're going to read it as 2,165 10,000ths. Our next example is 0.072. Again, if I place that in my table, I have 0.072, and this number ends in the thousandths column. So when I read this number correctly, it would be 72 thousandths. Our last number is 0.19417. So 0.19417, just write that in the chart, and I'll see that this time my number ends here in the 100,000ths column. So when I read this number, I'm going to read it as 19,417 hundred thousandths. Now that we've reviewed reading decimals correctly using the place value, we can move on to the next part of our lesson, which is finding the square root of a decimal. We have 3 steps. The first step is you're going to read the decimal. And when you read the decimal, you're going to make sure that you state the place value. It's very important that you include the place value. So for this first example, when I read this, I'm going to read this as 36 hundredths. The next thing I'm going to do is I'm going to write down exactly what I read. So I read that as 36 hundredths. I'm going to write that fraction. 36 hundredths is 36 over 100. From there, we're on the third step, which is to simplify. This problem has just turned into one of the previous ones that we did, where we're finding the square root of a fraction. So remember, the square root of 36 hundredths really means the square root of 36 over the square root of 100. When I simplify the top, the numerator, I get 6. When I simplify the denominator, I get 10. And this one does need to be reduced into simplest form. So we would say 3/5 as our final answer. My next example, I'm going to read what's in the radical, right? When I read what's in the radical, I'm not going to say 0.09. I'm going to say this is 9 hundredths. And then I'm going to write down exactly what I said. So I'm going to bring down my opposite sign. There's my radical, and this is read as 9 hundredths. Again, I'm going to rewrite it just like we did in our previous lesson. Square root of 9 over square root of 100. There's a negative sign in this problem, but that's okay because it's not inside the radical, it's outside. The square root of 9 gives me 3, and the square root of 100 gives me 10. That's already in simplest form, so negative 3/10. For our next example, when I read this one, I'm going to read this as 49 thousandths. Now this one is a little bit tricky because the top number, 49, is a perfect square. However, the bottom number is not a perfect square. Even though it has zeros in it, it's not a perfect square. 100 is a perfect square, 10,000 is a perfect square, but a number like 1,000 is not a perfect square, therefore we can't simplify that. There's no number that I can multiply to itself to get 1,000, no whole number. I would need to have a decimal. And just to show you, if we did 10 times 10, that gives us 100, right? But if we did 100 times 100, that gives us 10,000. So we don't have anything that I can multiply to itself to get 1,000. So this one again is no real roots, because that is something that's impossible, right? We can't have a decimal in the bottom of our fraction. Our last example, when I read this one, I would say is 121. And if we're not sure of the place value, let's count, right? This is the tenths, this is the hundredths, this is the thousandths, this is the 10,000ths. So it's 121 10,000ths. When I rewrite that, it's going to be the square root of 121 over the square root of 10,000. Now this time I can simplify it. The square root of 121 is 11, and the square root of 10,000 I just figured out right here. So the square root of 10,000 is 100. 11 over 100 is already in simplest form. So there's our solution. The last thing we're going to go over is actually the first thing that's on your page of notes. Squaring a number and finding the square root are opposite, or what we call inverse operations. In other words, they cancel each other out. Our first example is the square root of 5 squared. If I were to simplify this, I could rewrite this as the square root of 25, which we know equals 5. Let's put a few more examples down so we can see what happens. The square root of 9 squared is another example. 9 squared is 81, and when I simplify the square root of 81, it gives me 9. One more example we can add would be the square root of 12 squared. 12 squared is 144, and when I find the square root of 144, I end up with 12. If you notice in every single one of these examples, the answer that we ended up with was the number that we started with inside the radical. Here we ended up with 9, and we can see that our initial problem was the square root of 9 to the second power. Here we ended up with 12, and again, that was the number that we started with. The reason for that is because finding the square root of a number and putting a number to the second power cancel each other out. So for our first example here, if I were to cancel out this radical sign and the exponent, I'm simply left with the number 5. Same thing for our second example. If I were to cancel out the radical sign and the exponent, I'm left with 9, just what was inside. And our last example, the square root of 12 squared, by canceling out the radical sign and the exponent, I'm left with what's inside. That being said, if I'm solving the square root of 45 squared, I don't have to actually put 45 to the second power. I should know that this radical sign and this exponent are simply going to cancel each other out, and I'm going to be left with whatever's inside, which in this case is 45. Our last example is the square root of 19 times the square root of 19. Since I'm multiplying the square root of 19 to itself, I could rewrite that as the square root of 19 squared. Again, based on what we've been saying, the radical sign and the exponent of 2 cancel each other out, and we're simply left with what's inside. So it's the same problem, it was just presented in a different way.